Okay, welcome back. So now we're going to discuss environmental regulation in the United States. Um, Laws have been passed in the U.S. to strictly regulate the following three types of pollution. Let's see, hopefully you guys can see me. We got emissions, effluents, and waste. Now, it's not a coincidence that these correspond to gas, liquid, and solid. So an emission is a form of pollution that's something you can breathe in, gas. Effluent is usually liquid, something that you could drink but probably wouldn't want to. And then waste is something that's like solid pollution. Okay. Beginning in the 1960s and 70s, again, when you start having that kind of distrust of business that we've talked about a couple times, beginning in that 60s and 70s period, Congress began passing a lot of regulation governing industry, in particular with pollution. The biggest one is they established the Environmental Protection Agency, the EPA. It's an executive branch regulatory agency, and its mission is generally to protect human health and preserve the environment. Okay. So there's some areas of environmental policy with air. Of course, under the Clean Air Act, there's certain aspects of national air quality that have defined certain gases as pollutants. Do I expect you to understand the science behind all of these? No. We're not scientists, okay? I expect you to at least be able to know enough that you're dangerous and can ask questions when dealing with ambiguity, though. So, of course, we know carbon monoxide is a pollutant, so is nitrogen oxide, sulfur dioxide, ozone, any other kind of particulate matter, including lead. And we define hazardous air pollutants as chemical emissions that are seen to pose a risk of serious illness, including cancer or birth defects with small inhalation exposures. We'll talk a little bit more about how you test that in the next lecture. And the Clean Air Act means it gives the EPA the right to set emission standards on 187 different air toxins at levels that prevent disease and require industry to use the maximum achievable controls to comply. We also, when it comes to air, we also have to deal with acid rain. That's caused by sulfur dioxide and nitrogen oxides. Most of us in our lifetime have probably not seen a lot of acid rain, but you can see the evidence of it. I remember going to the East Coast, and particularly in New England, and you would look at some of the old churches, and you'd look at the sculptures, and you'd notice that there was like a discoloration on a lot of the sculptures, also on gravestones, and the art and the designs had been worn away. That's usually indicative of acid rain at some point. So it's actually eating away the stone. So it's acid in the rain. We also have to worry about ozone-destroying chemicals like CFCs or chlorofluorocarbons. I don't know if people still do this, but I remember as a young child, CFCs are used in coolants, like refrigerator coolants, old air conditioning systems in cars and these kinds of things. And you would hear stories about people going down to like Mexico and buying CFCs there because they either couldn't afford a new refrigerator, they wanted to keep their old refrigerator, they had like a classic car and they were using the air conditioning system, repairing the air conditioning system using the kind of original CFC gases. I don't know if people still do that. I haven't heard much of that. But at least that's when I usually think of CFCs. And CFCs are particularly dangerous because one molecule of CFC can damage or destroy thousands of molecules of ozone. So they are very dangerous to the environment. I suspect the demand for CFCs is reduced as more and more industrial appliances no longer require CFCs to cool effectively. Of course, we also have greenhouse gases. I know you've heard these in the media. Those gases that absorb energy that's normally radiated from the Earth, and they trap that energy and keep it from being released into space. CO2, of course, being one of the primary offenders. Now, in terms of water, there's also water pollution control acts, and while it's a great idea, you can control some runoff from factories and companies. A lot of the runoff is generally uncontrolled. Of course, you have agricultural runoff. People that own farms, you're looking at fertilizers, material from soils, and that can either go into a stream or it can seep into the water table and cause a lot of problems too. And that's very hard to regulate because you don't always see the people. You can't have a government observer watching at all times to prevent agricultural runoff. Some of you that are here in Southern California may know about the Salton Sea, and we're going to watch a video in class to show the environmental catastrophe that is the Salton Sea, and a lot of that was caused by agricultural runoff. So because the agricultural runoff, you have botulism waves, so the fish will die off in masses from botulism poisoning. You have these weird algae blooms. The fish that eat the birds that eat the fish die. I mean, it's just a scene. It's just a scene of death, and that's one of the unfortunate consequences of agricultural runoff. And then you have urban runoff. Now, some of it, there's dirt and stuff in your tires. It rains, the grease seeps up, and then it runs off, and it maybe gets into the ocean or the water table. But then you also have people, pouring paint down the sink, pouring paint down those wells. Many of you, I'm sure, have seen those little things that say, "Don't dump anything in here. This goes into the ocean." That's trying to prevent urban runoff. Now, there's also the Resource Conservation and Recovery Act, where firms have to label and store and treat any sort of hazardous waste under very strict guidelines. Difficult to administer and difficult to apply, including with landfills. Now, think about why that is. Of course, again, it ties back into bounded rationality. No government agency, including the EPA, can actively supervise every single landfill and every single company at all times to make sure they're doing exactly what needs to be done. I'm sure you've looked at some of the pictures of landfills. If any of you can't understand what that's trying to show you, I bet you there's a lot of other people out there who have no idea what that's supposed to show or how it's supposed to be monitored. Again, it takes real technical expertise to monitor some of these landfills. There's not enough people doing that work. They're not paid enough. They can't be everywhere at the same time. So it's very hard to monitor these things. We also have the Superfund. That's the Comprehensive Environmental Response Compensation and Liability Act. It's supposed to clean up toxic waste sites. It has cleaned up some. The cleanup work started with a total of a little more than 1,000 sites. There's more sites now, and only 325 have been cleaned up as of now. Cleanup process is difficult to predict. It's expensive. It's just going to take time. So, this concludes our discussion of the environment. I hope you found this discussion interesting, informative, entertaining. My name is Duncan Pelly, and we'll see you next time.